Hey, this is Bentley Adkins. This is assignment 5 using the GAN, the Generative Adversarial Network, which utilizes two neural networks, the generator and the discriminator. The generator generating the fake images, and the discriminator actually deciding whether or not, using probabilities to see whether or not it is fake or real. So we start off with loading in the libraries and everything. I didn't include the Google Colab one because we didn't need to pull anything from the drive. So everything was just pulled from the MNES data set, which is a data set that's already ran with Torch. The first thing you have to do is open the terminal and run this, do pip install torch info, so that you can see the summary of the neural networks that you build. It makes it a lot easier for distinguishing what's happening and what's happening to the model and what the summary looks like. So this is the generator. Since we had switched from uh, an MLP based neural network to a CNN based, we use the same principle with the autoencoder to get it down to 7 by 7 and then decode it and build it back up. So it's essentially what we're doing. So we have our first one's linear, and then we use the bench normalization. Then we use our activation function as ReLU. Then we upsample it by a factor of 2, so then it goes to 14 and then to 28 by 28. And then we have our convolutional layer. Um, then another batch normalization. And then we have our second one for the grayscale images. Since if this would be a 3 if we were working with RGB, because we use 3 channels for RGB, but we only needed one. And then we have this the tan age activation for values between -1 and 1. And then we have our forward pass. I'll save some time and not explain all that because it's all pretty much there. And then we have the discriminator, which is actually telling the difference between the two, whether of the generated images, whether or not it's a real image or a fake image. So then we used max pooling, which we used in the convolutional CNN assignment. Then we flatten the array, then we do a leaky ReLU, and then we build a sequential, and then we also have our forward pass here. And then we initialize our device to use the CUDA GPU. Then we have our generator and then our discriminator, two devices, and then this is the summary of our generator. You see it in 28 by 28 and it's shrunken down to 7 by 7, and build back up. And then this is our discriminator's summary output shape. And then this is just getting the data from the MNIST data set, getting the X train, the X tensor, and getting the valid and fake variables. And this is our criterion, which is we use binary cross entropy, and then our optimization for the discriminator and the generator was both with Atom. And then this is our actual training. So we're in 10,000 epochs to get the for training the data. So we have the sample images, and then this is the train discriminator, and then we have the train generator, which initializes our optimizer for zero gradient, our criterion on images with the valid and then the fake ones. And then we have our loss. And then this is the same thing, but for the generator. And then this is just generating text for the epoch. And then this is the accuracy. And so this essentially is for every 200 Well, every 200 epoch, it generates a picture and stores it in a folder over here. I don't have the runtime active right now, but it would appear in a folder here. And this is, and it's also generating the images. So, and then I ran this to actually just generate one of the images using matplotlib to see what it looks like. So you can see it here. It did pretty well with like 3, 7. I thought was pretty okay too. I think the zeros and the eights it got messed up on a little bit. Like it has the same oval shape of a zero, but has a line through it like an eight. But this one has the same shape of an eight, but however, it's missing a little bit here. The 6 was pretty good too. And then 9 was okay. Sometimes I think it replicates a 1 whenever it's not supposed to, but yeah, I think that's it. That covers everything. So thanks. I'll see you.